My name is Steve Nelson. I'm Master Principal Architect for Oracle Cloud. Leo and I are we've been here, probably the oldest of everyone here. Leo joined a little bit before I did. I was the second solutions architect hired for Oracle Cloud specifically. I came from AWS, and one of the things that we were always told was, come here and do it better. What would you do differently when you join here? What would you do differently than what you did at your current cloud provider? And this is really kind of a representation of what we would do. I was, up until recently, I was part of compute engineering. I was the lead architect and the product manager for the VMware solution. So I was in the position of really guiding and leading a lot of the architecture and technical development around this solution. So it's as well as managing the partnership in a lot of ways. So a lot of background in that, as well as kind of general purpose OCI types things as well. So I can address a lot of those questions. So let's talk first about what the partnership is. The partnership really with VMware has a couple of different things other than just us putting VMware inside OCI. We're talking about moving and extending the fleet to the cloud. We are a member of the VCPP program. We sell the solution. We are the seller of record for this solution. And we also the provider of support. So we are the first throat to choke, the first people to call when you have a problem with the VMware pieces here. The partnership also works both ways. We're also extending Oracle database support and applications onto VMware. So previously this wasn't the case. And so we've truly developed this as a partnership between both OCI, both Oracle and VMware, so that we both are benefiting our customers to the maximum extent possible. So what is the product itself? It's the Oracle Cloud VMware Solution. And I want to emphasize solution here somewhat, because we're not providing this as a service. This is a true product that combines the OCI infrastructure and the VMware software and architecture into a VMware Cloud verified solution. So this is a joint engineering project that we took on with VMware to provide a solution that would allow customers to do things the way they wanted to do this. So it is the VMware software, the Oracle infrastructure, and then you can integrate it however you want. So right now, we are running this as 6.7 or 6.5. So the software itself is installed and provisioned onto our bare metals dense IO systems. We are running this as vSphere 6.5 or 6.7. We have running NSXT and vSAN. We also provide HCX Advanced as part of this solution right now. Now, note this is 6.7, 6.5. We are launching VMware 7.x in limited availability as we speak. We have a GA date that's coming up that we'll announce once it's ready, but it is fairly quickly coming. When we launch the 6.7 and the infrastructure today, we launch it in a minimum 3-node cluster. Well, why is that? Well, vSAN has to have 3 nodes to form. So we use our NVMe storage that's built into our dense IO shapes to build this cluster and have the data store running utilizing those NVMe's, that local NVMe storage. Each of our nodes is 52 cores, 768 gigs of RAM, and 51.2 terabytes of NVMe storage. And combined together, that gives us a fairly large footprint that can cover a lot of ground for a great number of customers just by deploying a single 3-node cluster. Now that cluster can be expanded as needed, and we can talk about that a little bit later on, but we can grow that cluster all the way to the maximum supported cluster size of 64 nodes in VMware. This is one of those things I coined inside when we're starting to talk about this to our internal customers. It's just VMware. Remember when I talked about the fact that we're developing this as a solution and not a service? What we effectively did is we developed a provisioning service, which then takes an image of ESX deploys it onto our bare metal systems, does some basic configuration of vCenter, vSAN, and NSXT, and hands the whole thing over to our customer. So there's not a real difference between what they see on premises and what they see inside OCI. It's exactly the same VMware. We're not wrapping it with some special administrative package. We're not doing any kind of special things to VMware to make it work inside OCI necessarily. We're not, fundamentally preventing customers from doing things to their OCI environment. This is just VMware. And you can manipulate it and do the things you want to do with it, just as you expect to do it today.
So, Stephen, on that note, do you do anything to prevent your customers from shooting themselves in the foot? Because they can probably get into a situation where, oops, I turned off my vCenter, or I messed with the networking on the hosts, or something like that, and it's basically in an unusable state or something like that.
No, actually, we don't provide guardrails other than warning customers that the same things you wouldn't do on premises would be the same things you wouldn't do inside OCI. You get that same level of administrative access. So if you're on premises, you wouldn't go out and just willy-nilly delete NSX Manager, for instance. You would have things to do that. Now, having said that, we do some protection of those types of things. So we have vCenter in an HA configuration. We have multiple NSX managers running. We have multiple edge nodes that are out there that provide the interface to the overlay networks. So there are some kind of basic protection mechanisms out there that will at least keep customers from doing grievous things to their environment unless they're really, really intent on doing that. But fundamentally, we believe that customers can make their own choices, and some of those choices can be detrimental to doing that. Now, they can open support cases with us, and we can come out and help them, recover from those types of things and do those type of activities. But fundamentally, it's the customer's responsibility for maintaining that.
So in that case, is this any different than if a customer just deployed vSphere to a bare metal instance in Oracle Cloud Infrastructure? Are there additional value adds like lifecycle management or automated scaling or anything like that you don't get that make it a more managed service? Since I get to do anything I want, do I have to do everything myself?
Well, we took the approach of that we didn't want to provide this as a managed service. So there's not the automation you would see around auto scaling the number of nodes today. So those are things that we're definitely looking at, but fundamentally we want to take this approach of we want to match the operational model as much as we possibly could as we see on premises. Because in interviewing and talking to a lot of customers, part of the problem with some of the other solutions is, well, I can't apply a VRO in the same way that I do on premises. I can just swing it over. As a matter of fact, one of the things that we did when we were deploying and building this solution was we had a functional validation program, and we had a select set of 10 customers that broke free their time to see what a alpha solution would look like and tell us what we should do and shouldn't do. And one of the telco customers I was working with, I was like, well, look, take your vRealize, your automation, your vRealize, point it directly at this thing that we built on a bespoke basis that represents what this is going to look like, and just run it and tell me what happens. And fundamentally, they didn't have any changes. It deployed their VMs the way they thought they would. It deployed all their overlay networks the same way it did. It did all that. And that was a really good kind of indicator for us to say, hey, customers just want to keep it's a lot of cost to change your operations in the face of just shifting to a new platform and which should be the same platform because it says it's VMware, but I have to make all these changes to my backend automation. I have to make all these changes to my current operational model. We wanted to eliminate that, and that was some of the design goals in doing that. Now, we gave up in the interim some of that automation that's there as far as detection of load and auto scaling things out. So So customers have, we made kind of an assumption that customers already have that kind of baked in. People have been doing VMware for decades and have baked in a lot of operational experience doing that. So that's kind of the approach we took about why there's not that out there. But that's the fundamental piece of it right now.
I have a real quick question. Earlier in the presentation, and maybe I'm wrong about this, but it looked like from a bare metal perspective, all the VMware stuff aside, you had the ability to create your own bare metal hosts and customize the amount of resources you wanted, CPU, RAM, and so forth. Is that something that maybe you're looking into as well for the solution to allow customers to have a sliding scale cost where you could create your own host, maybe with a minimum, but also customize what type of host that you're going to have for the solution?
So the item that Leo demoed there, as far as the sliding scale on the instances, was around our VM, our virtual machine instances. So those are around those things. The bare metal instances, by definition, and actually that's a great lead in for my next slide. The bare metal instances themselves, you can think of them as being an API mechanism to give you access to a piece of hardware that you don't have to rack and stack and install yourself. So from a sliding scale standpoint, there's not a way to scale up and scale down the number of CPUs, just like there is an on-premises to go in there and easily go in and fence off and physically turn off CPUs, because we're essentially, through the bare metal instance, just giving you the ability to say, hey, today I want 5 pieces of hardware in my rack. Okay, I go into the API, I go with my Terraform, I deploy those into my tenancy, which is my virtual rack, and now I have access to them with the operating system deployed on this. And where this kind of comes into play for the VMware piece is, we didn't change that model from how we do bare metal instances with operating systems like Ubuntu or CentOS or Windows running on this physical piece of hardware. All we really did was say, we're going to add another operating system to the mix, and the operating system happens to be called ESX. And we're going to do some special things on top just to make sure it runs the way we want it to, and then give it to the customer just like we would anything else. So we didn't create any special pool of hardware. We didn't create any kind of fenced off data center, or we didn't create this anywhere else. This simply draws from our existing fleet of hardware for our bare metal shapes, and happens to put this different operating system in there in an initial cluster, and then adds individual onesie twosies as you want to, going on the path to do that. As you can see here, we just talked about, we didn't really create any pools of hardware or anything else, because we wanted to make sure that when a customer came in to deploy this, that their experience in deploying this and their experience in interacting with the other services was no different than what they would with any other operating system. Consistency, and Leo touched on this a lot. Consistency of presentation, consistency of regions, consistency of how things work. We are very much into and want to make sure that when our customers interact with OCI, that they get a consistent operational model that they see all the time. That means you can deploy the OCVS with Terraform, you can use it with our Ansible provider, it's drawing upon the same fleet of hardware, which means it gets access to the same networking configurations and has the ability to interact with the OCI services, just like anything else that operates within OCI. It's a first-class citizen and first-class service. And to that extent, it takes advantage of all the networking goodness that we've developed along the last 4 years around how our networking works. So it participates in our VCN, which is, if you're an AWS guy, that's a VPC equivalent. You have the fully configurable subnets, firewalls, and routing. IPsec and VPNs. You have 25 gig network infrastructure. You can get to the instances and the virtual machines inside VMware via Fast Connect, which are our private link type of environment that it has there. Load balancers can interact with the VMs running in OCVS. The VMs inside OCVS can have access to the services through Service Gateway to things like autonomous, things like our functions, all those types of things are that in there. And then having both private and public DNS that are provided as a service within OCI being accessible by the various VMs and all the components around that. So, this would be kind of an overview of what a typical region would look like. And I'm going to get into what our L2, the thing that I'm going to go back for just a second. The one that I skipped over there on purpose is the industry's first L2 layer 2 network. And we're going to talk about that in a second. This would be a typical OCI deployment. We have subnets, we have virtual cloud networks across all the availability domains, access to all of the services you have there, having a fast connection back to on-premises environments, all of the things that you would expect from a public cloud. OCVS plugs directly into this and simply allows you to go forth and access these things and be accessed by on-premises. One of the things we did, though, we recognized as part of the deployment of OCVS is that if we're going to deploy this as it is on premises, there has to be some layer 2 capabilities. We need the ability to float IP addresses. We need the ability to create and move MAC addresses. We need the ability to issue GARPs and those type of things. So what did we went out and we actually built the layer 2 network that's equivalent to our subnets that allows VMware to operate just as it does on premises. So the vast majority of the activity and network activity that VMware does runs over this layer 2 network equivalent that performs all the layer 2 activities that a layer 2 subnet does, but still has all the layer 3 and above services available to it. So this layer 2 environment provides the native services like GARP and ARP and RARP and all those things without any kind of abstraction. We don't have any kind of special API calls or anything else that happens under the covers. It really is just a layer 2 network. We can do things like allow multiple CIDR ranges on the subnet. We can have MAC addresses that are defined by the customer. We can create multiple virtual addresses without pre-provisioning the IP address space into the subnet. We can stack all this stuff together. So right now, this is exclusively used for OCVS, but we're extending that. We'll be extending that out later in the year for the general purpose use case. So you'll see more and more kind of these hardware-based services that are expecting layer 2 to come onto OCI because we can provide a layer 2 network that allows them to go do that. The other thing that OCVS allows you to access is we still maintain the same amount of governance and access in doing that. So all IAM things that allow you to control of the cloud, all the things that are built into that are still accessible. You can still track who does what. You can tell people who can provision and everything else. You get notifications about the state of the nodes in the cluster. You get the monitoring of that environment. You get to audit all the events that come out of those in terms of how this has been provisioned and what's been going on in the environment. And you get the cost analysis dashboard around doing that. So all the things that you're expecting out of your public cloud pieces, for the most part, are being part of the OCVS experience as well.
Hey, Stephen?
Yeah.
I have a question regarding the identity component.
Yeah.
One of the things that's really common to do with virtual machines or instances in the cloud is for them to be able to query a metadata service and get an identity-based token so they can assume a role or do something in the cloud.
Right.
Can you extend that down to the virtual machines you're running on the VMware cluster where they can also query a metadata service and get an identity, or is it just per bare metal host that identity exists?
Yeah, but right now it's just per bare metal host. So there's not a way to extend that metadata service into the VMs currently. I will tell you that's something we did consider, but we're not. There's a number of kind of challenges around how do we extend that metadata service in a secure fashion across the NSX bridge, if you will, into the virtual machine, so that is targeted to only the instances that are there that we want them targeted to. Because the way our metadata service works in OCI in general is that token, that API token that's provided, is unique to that virtual machine. So how do we create a unique virtual machine identifier within VMware, which is essentially a foreign hypervisor to us from the OCI perspective, in such a way that we can guarantee that token is unique to that virtual machine, and that if that virtual machine is created and destroyed and recreated, it doesn't re-grab the same token. So there's a bunch of integration pieces there that are really, they're difficult problems to solve in terms of identity extending out to virtual machines inside the VMware environment.
Okay, thank you.
Mm-hmm. So along with the identity pieces here is we have all of the security pieces along with it as well. So traditionally, the security is tied to kind of this combination of the hypervisor, the virtualization, all these things. What we did, and this is true across OCI in general, but it will specifically to this, is that the virtual network itself is completely isolated. We have off-box virtualization of the network that completely separates the relationship between the virtual network interface and the operating system, or in this case, hypervisor, that uses the bare metal instance that's above it. So part of the things that I was also responsible for was the integration of KVM and the deployment of Hyper-V. So we took that and extended it out to ESX, so that we can say that the virtual network interface layer has its own security boundaries. It has its own security mechanisms, which we deal with on a per packet and traffic level basis. That is independent of the upper level components. So just like kind of the paradigm of cloud anyways, which is the disaggregation of compute from storage, we've also taken that down, so we're disaggregating network from compute from storage, so that we can really create these intricate security boundaries about who does what, when, and where, and which individual interfaces have access to what other individual interfaces, without necessarily having to define that at the operating system layer. We can do that within the network layer itself.
I have a question about the way in which you're achieving that. Do you have a smart NIC that's going in each host that's handling that network virtualization layer, or is it actually being handled outside of the server at a switch level to handle all that processing?
Yes. So the answer is there is a smart NIC that goes in. There's an off-box virtualization smart NIC layer that is in every single device that we deploy. So that is, regardless of its virtual machines or bare metal, each one of those devices get that off-box virtualization. And so that's just part of our standard fleet. That comes back to kind of that fleet mechanism, that fleet paradigm of everybody gets the same off-box virtualization. And then in doing that, we create our control plane allows us to create relationships between the various off-box virtualization components that isolate them from every other component that's out there. So I'm going to take this back to kind of the basic OCI stuff as well, where if I have a virtual machine running in our hypervisor, it's going to get a slice of that off-box virtualization, and it's going to give its own MAC address. In a multi-tenant environment, I may have another virtual machine on the same hypervisor that also gets a different slice of that. The back-end control plane allows us to isolate those two things from each other in such a way that there's no crosstalk or anything else. What we did is we took that and extended that to the bare metal side as well, and said there's no reason why, and there's actually a technical imperative to make sure that the bare metal instances participate in the virtual network in the exact same way as the virtual machines do, so that they maintain the same hardened relationship between the two of them across the VCN itself. And then we further extended it out to say the ESX VMware cluster has to also participate in that in the exact same way so that we can maintain this hard isolation between every participating instance within the customer tenancy.
Okay. The off box terminology is a little confusing to me. Like, where is the box? How are we defining a box?
It's physically attached to each individual bare metal instances there.
Okay.
Okay.
So
you can think of it as a loop. So there would be a hypervisor or a network interface that loops out to the physical off-box virtualization for that particular piece of racked instance, and then that goes up to a switched environment, which creates a flat network for everyone to participate in.
Okay. I think I get it well enough to understand what's going on. Thank you.
Just as an aside, there's a great blog that our lead architect on this, Lucas Stickles wrote. That will give you a great overview of how the off-box virtualization works and how L2 works as well. Okay, so I want to quickly go over some of the key benefits here. Dedicated with full control, the same VMware tools, migration and access to services, as well as global availability. When you get OCVS, you get full root and administrative access to the environment. Once we deploy this, we no longer have any access to via the VMware cluster. There is no interaction from us. We believe in that zero trust environment, so you get that off-box virtualization, you get that access to do those types of things. You get the full root administrative access to do that, and we have backed away from that and said, this is your environment. So we don't have any managed service environment to consider. There's no multi-tenancy involved with this. This is your environment. This is strictly your bare metal instances running VMware in your tenancy that you control at your discretion. It's the same VMware tooling that you use today, including patching, upgrades, those type of things. If you want to apply a VIB to ESX to say turn on Zerto, you can do that. We are not restricting you from doing that. If you want to use VRO and VRA and VRNI to manage your environment, you can absolutely do that. They work exactly the same way as you'd expect them to work on premises. Again, coming back to my tagline, it's just VMware. There's no differences there. So you can leverage all their best practices. You don't need any new training sets required. You don't have to do anything other than manage it the way you expect to manage it on premises today. Because of that, it's easy to migrate. I can use vCenter replication. We include HCX Advanced. We're going to be releasing HCX Enterprise here shortly. So you can do all the migration skills. You can use traditional backup and recovery with pick your own backup tool. All the things that you to do today, you can continue to migrate. You can migrate everything up there just the way you expect them to do. We can extend that layer 2 piece through the HCX tunnel across the Fast Connect and do your migrations just as if you would on any other platform. And then lastly, VMs, for the most part, with the exception of what Ned pointed out, and that was a great exception, thank you for that. VMs that run inside OCVS are first-class citizens. They access the Oracle services in the exact same way as the VMs that we create natively inside OCI. VMs, and then the VMs within OCI and the VMs within the VMware OCVS environment can access each other as a peer relationship. You can prevent access by setting firewall rules on NSX or putting security list rules or network security groups inside OCI. So all of those connectivity issues, all of the ability to connect between services, all of those things, because it's part of the fleet, because it's part of our native VCN infrastructure, because it takes advantage of all the things that all the goodness that we developed for OCI natively. It is an equal participant. It is a first-class citizen. Any VM is a first-class citizen inside VMware, just like it is within OCI. And then lastly, the VMware OCVS service solution is a first-class citizen within the region. So that means that every time we stand up a region, OCVS is automatically there. It's part of our region planning process. It allows us to get this out to, every single new region that comes out will always have OCVS. Why is that? Because it's a first-class citizen, because it's the same fleet that we use for everything else, because it doesn't require any fundamental changes to our environment to do it. We can get OCVS out to any region we want to, including the dedicated regions that Leo mentioned as well. So because dedicated regions are just customer deployed regions in their data center, and we deploy the same services we would inside a public region, the dedicated region pieces also get OCVS as part of their environment. So there's no differences there. We can deploy this as needed to whatever region that customers want to stand up for themselves. And when Singapore comes online, for instance, it will have OCVS at day zero. The basic use cases you'd expect: migration to the cloud, the expansion capacity, and disaster recovery. We have a number of models for each one. And this is what you'd expect. You can do vMotion over Fast Connect. You can establish HCX and do the migrations over this for the migration standpoint. You can have some pieces still on premises. You can have some pieces running inside OCI. Because it's just VMware, you can do vCenter Enhanced Link Mode and run them from your on-premises environment as one giant VMware environment. We haven't made any changes to that. And then from a disaster recovery standpoint, you can use your favorite version of disaster recovery mechanisms and apply all the BCDR planning that you have for the same mechanisms that you did for on-premises. And that's a huge time savings, especially when you're talking about enterprises that are looking at how can we expand our DR environments without having to take the cost of having hardware that's sitting there idle doing nothing for us. As I stated, support's provided for this by Oracle. We're the tier 1 and tier 2 support. If there's something that requires engineering, we will do a warm handoff, open the tier 3 case, and do the case management for that handoff. Now, I will say that if someone calls us and says, hey, VRO is broken, we're going to hand them off to VMware. We're only supporting the pieces that we provide. So that's the vSphere, that's the vCenter, that's NSXT, and that's vSAN. If there's something outside of that range, that has to be provided by the VMware pieces. And if someone calls us and say, hey, my ESX server doesn't work on premises, we're going to have them call VMware too. So you get the full benefits of everything that's there. You get to maintain your environment. You get to leverage the existing expertise, manage all your changes, do your patching when you want to and if you want to. If you want to stay on ESX7, you can do that. And you get to integrate with all the cool services that are there, including things like Resource Manager, including things like Autonomous Database. All those pieces are available for you to use. So run your VMware workloads natively. Keep doing those type of things. Take advantage of the fact that you can migrate to the cloud and take advantage of the elasticity of the cloud by adding and subtracting nodes to VMware as you need it. You can continue to use that and then migrate other services to the cloud, make them cloud native, but continue to operate VMware for your legacy applications. It really gives you the flexibility and the ability to come out and do the type of operations that you need to do to keep things going the way you want to keep going.
Hey, Stephen, I have a question about adding additional nodes to that vSphere cluster, or multiple clusters, I guess you can have. What's the average ramp up time for adding another node to the cluster?
So spin up is about 45 minutes for a new node. The initial deployment time for the initial cluster is about about 2.5 hours, depends on a number of different things. So it's kind of roughly in there. The adding additional node to spin it up to get it deployed is about half an hour, 45 minutes. But then you're going to still have to go into vCenter and then add it to the cluster and get the vSAN synchronization going. So there's some overhead time at coding with that, but our spin up time is no greater than it is for any other operating system to deploy into bare metal.
Okay, I got you. And I think somebody asked this earlier, but if I did want to deploy just a bare metal instance with ESXi running on it, that is not a supported configuration today?
No, it's not currently supported today. I'll say that just stay tuned. We recognize. I'll say that what I can say is that we recognize the need for the smaller instances and the smaller shape sizes and things like that.
Right.
And so it's not something that we are ignoring or anything else and saying, oh, you got to deploy this big thing and whatever. We recognize that there's a definite demand for that, and there'll be things coming out potentially that will address that.
Okay. Yeah, I was looking at the pricing, and it's about 10 times the cost to run the VMware node than it is to run a bare metal node of, like, I guess roughly the same size, but I assume you're bundling the VMware licensing in there.
Yeah, that's a good point. Thank you for reminding me on that, is that the licensing for all that's included. So the VMware licensing, or the VMware OCVS solution, includes all the licensing for NSX, vCenter, vSAN, and ESXi at the enterprise levels for those type of things. And so you're not bringing your own license to this party. You're using our existing licenses that are provided as part of the solution to do that.
Okay, cool. Can you bring your own license?
And just like any other public cloud provider, you cannot bring your own license.
Okay, I didn't think so.
No, I mean we're under the same constraints from VMware that GCP or AWS or Azure are.
Okay, cool. Thank you.
Yeah, I was just wondering about something.
Sure.
So, for example, you must have a fair number of Oracle customers, right? If they are deploying this environment, do they get or other customers get Oracle licensing mobility on this platform, or some benefit in that kind?
So the Oracle licensing levels haven't changed as part of this relationship. So there's, if a customer has an existing cluster and wants to move an Oracle database, they can move that provided they have enough CPU licenses to do so. So this is, customers can move the Oracle databases to this environment, but there's licensing constraints as far as the number of CPUs licensed for the particular software and instances that are there that have to be followed. So it's not that we're preventing the license mobility. It's that customers have to be very cognizant of what the costs are of doing that. In particular, the database costs and things like that, it may be in a lot of cases more economical and, quite frankly, probably from an operational standpoint, better to move to something like DBaaS, which are database as a service, or rack on OCI, or XSCS, or autonomous, depending on what they're trying to do that, because there's a lot more elasticity there, just from a straight operational standpoint, to have the ability to really right size what their licenses are in those particular environments.
And one other question is that, sometimes customers might need some other configurations, like, I don't know, they want in their hosts 10 GPUs slotted in as well. Do you support such configurations?
So that's something else I would say, stay tuned. We are looking at that, particularly when we start looking around VDI deployments. So you'll start to see there's an existing white paper, which I actually happen to author, about Citrix deployments. There's an existing white paper that's coming out. There'll be a white paper that's coming out very shortly about Horizon deployments. Those are into the existing environments and the existing OCVS environments about that. You should expect that maybe with a deployment of a different shape size a different shape profile, that there would be additional considerations on how you deploy that and the ability to take advantage of some of our GPU shapes that we have available as well to do those exact same things. Because we recognize that there are, particularly in the VDI space, there's a number of different areas where we can provide a lot of value to our customers by having this flexibility.
That's right. And obviously there's machine learning and all those kind of applications as well now coming through. So that's why I wondered.
Yeah, and the machine learning pieces, we have a whole HPC cluster service that's out there that, quite frankly, that takes advantage of the GPUs already by itself, that may or may not be as more efficient than what you're doing, depending on what the operational model is. But when you're talking about things like rendering, like visualization, CAD CAM, those type of things, where you want to put high performance desktops but not have to buy GPUs for everybody on their desktop, we're definitely looking at that. And I would say stay tuned towards the end of the calendar year to see what happens with that.